Volume of prisms. In this part of the chapter, we will learn how to calculate the volume of prisms through the use of cross-sections and cross-sectional area. Let's consider these 4 slices of bread. Now, how much bread is there? How do we measure? Is it through length, area, or is it through volume? So in this case, we are actually going to measure the volume of the amount of bread that is in here. Now notice that these 4 slices of bread are cut in the same direction, producing a particular cross-section, and each of these cross-sections have the same cross-sectional area. Each of these slices also have a thickness. Every thickness is also the same, resulting in a particular length of all the 4 slices of bread. So how do we find the volume? The volume of the bread in this case will be equals to the uniform cross-sectional area multiplied by the length of the solid. Similarly, what is the volume of all this bread down here? Each of this bread is also cut in the same cross-section, resulting in a particular cross-sectional area throughout every single piece of the bread. And all this bread will have a total thickness, which results in the length of the whole solid. So in order to find the volume of the solid, we will take the uniform cross-sectional area multiplied by the length. How do we find the volume of the following prisms? Now let's take a look at our first case. This solid itself has a uniform cross-section. Can you identify the shape of the cross-section and then find the cross-sectional area? Well, the shape of the cross-section is in the shape of a heart. So this is the cross-sectional area, and it has a cross-sectional area of 360 cm. So how do we find the volume? The volume of this solid will be taking the cross-sectional area, which is 360, multiplied by the length of the box. And that gives us the volume of the prism. How about the next one? This is a star-shaped prism. And where is the uniform cross-section? The uniform cross-section is the shape of the star over here, and with an area of 280 cm square, and it has a thickness of 2 cm. So in this case, the volume of the solid over here will be to take the cross-sectional area, which is 280, multiplied by the thickness of the solid, which is 2 cm. How do we find the volume of the following prisms? In the first solid, are you able to identify the uniform cross-sectional area of the solid? Now, where is the uniform cross-section? It takes on a shape of this shape. And this is the uniform cross-section. We can actually cut it into the shape of a trapezium and a shape of a rectangle. So if you're able to find the area of the cross-section and measure the length at the same time, we will be able to find the volume of this solid by taking the cross-sectional area multiplied with its length. Let's take a look at the second case. Now this is actually a can. Now where is the uniform cross-section? The shape of the uniform cross-section in this case is actually a circle. So if we are able to find the area of this cross section, which is a circle, multiply it with the length or the height of the can, we will be able to find the volume. What is the area of a circle? A circle with radius 3 cm has an area pi times the radius square. And in order to get the volume of this can down here, we will take the uniform cross-sectional area, which is pi r square, multiplied to the height of the can. And that gives us an area of approximately 283 cm cubed to the 3 sig figs. So, are you able to identify uniform cross sections of solids now? And how do you find the volume of prisms?